and pull up our first set of questions.
I'm going down to the videos.
Yeah.
And I'm not letting her. I tried dragging that.
Huh? There we go.
Okay, here's our first set of questions. Rationalizing. And we'll go ahead and do this one. Everybody got the desktop? Y'all can see everything okay? Make sure you maximize it if you can. Easily, can y'all see everything?
Yeah, we're good.
All right, so here we go. So the first one is 1 over the 4th root of x to the first power. So we're going to multiply top and bottom by the 4th root of x to the what?
The second.
Third.
Why would it be the third?
Somebody tell me why it would be the third. Because x to the first times x to the third is what? X to the fourth. Add your exponents. So that would be 1 times the 4th root of x to the third over the 4th root of x to the 4th, which will be cube root or 4th root of x to the cube over x. Fifth root. 1 over the 5th root of x squared multiplied by the 5th root of x what? X cubed.
You're going too fast.
Equals, what's x squared plus times x cubed?
X to the fifth.
X to the 5th. So that's going to be the 5th root of x cubed over 5th root of x to the 5th. And that's equal to the 5th root of x cubed over the 5th root of x to the 5th is x. All right, y'all try the last one. Now that I've shown you how to do the first two, try the last one. So, 1 over the 7th root of x to the 3rd, going to multiply by the 7th root of what? X to what?
4.
And that's going to be equal to the 7th root of x to the 4th. And what's the 7th root of x to the 7th?
X.
And that's how you do those. Remember, when you're talking about the 7th root, the 5th root, the 4th root, you have to think in terms of the index. You can't say, oh, that's x squared. No, you have to think in terms of what's the first thing that you can take the 4th root of, x to the 4th. What's the first thing that you can take the 5th root of, x to the 5th? And what's the first thing you can take the 7th root of, x to the 7th? And then you have to manipulate to get those problems. Okay? Next question. We got a lot of questions to cover, but we also need to be finishing up. People should be finishing up, should be towards your last three or four sections. Just letting you know. I think this is going to be our last week of review, so you need to get the homework questions in. On the Okay, this question right here on the scale of importance, this is from 0 to 10, 0 being not important, 10 being important. This is a 15. So you know it's going to be on the test. So anything dealing with the difference quotient is going to be on the test. Now, remember what I told you about functions. Anytime you're dealing with functions, and I'm going to go up here to the top, f of 2 means you're going to plug in what? 2 for x. F of -1 means you're going to plug in what? -1, wherever there's an x. So whatever's in that parenthesis means that you're going to plug in. Now, if you're given the function 8, there's the function right there, and you're told to do the difference quotient, then that means you're going to plug in something. Now, the difference quotient is right here. Now, a lot of you, I'm going to show you where that comes from. All right? Now, some of you, I asked you where that comes from. Can anybody give me a one-word definition of what that is? One-word definition, just one word, 5 letters. Okay, then I need to go over it. All right, so let me go up here. And I'm kind of jumping the review a little bit and giving you a little bit of calculus, but it's also a little bit of algebra too. So it's not going to... Everybody in here knows how to get the slope. I've showed it to you. We've gone over it. And I'm just going to draw 2 points right here. And this is x. This is f of x. Okay? Back a long time ago, this is x, and this is y. Okay? That wasn't sophisticated enough, so now you got to call it an f of x. This is, used to call it x of 2, and this used to be what? Y of what? 2. All right, and you know that, and I'm just going to write this the way we used to do it. This is x of 1, y of 1. This is x of 2, y of 2. And you said, okay, the slope is equal to y of 2 minus y of 1 over x of 2 minus x of 1. And everybody says, okay, I understand that. All right, now here is the calculus part, so pay attention, everybody. Some of y'all look like y'all are dead to the world, okay? Y'all with me? Pendleton, y'all all with me? Easily, y'all okay? All right. So my y of 2, well, like I said, this is not sophisticated enough anymore. Y'all are in calculus now, so y'all need to hold your pinkies up when you talk. All right? Hold your noses up too. All right? This is called x, and this is called f of x. Now, what is this distance called right here? Well, I'm just going to call it h. So what is this x right here? It's not x of 2 anymore. It's x plus what? And if this coordinate is x plus h, what is this over here? Now somebody give me the slope now. Write the slope down. Just like here. Go ahead, everybody. That means pencil in hand. That means paper. That means write. I think everybody's got a lazy peel this morning. Now, right now, some of y'all are going, I have no idea what the hell he's talking about.
0.
So, here's your x of y. Now, I'm going to take my red pen, and I'm going to write this point down right here. This is x, comma, f of what? X. This is x plus h, comma, what? F of x plus h. Now write your slope. Well, let's follow the thing we learned back in pre-algebra. M is equal to, I'm going to write a bracket here, minus bracket, y sub 2 minus y sub 1 over x sub 2 minus what? All right, now forget your old way of writing it because we're not rednecks anymore. So forget that and forget that. So, somebody tell me what to plug in right here. F of
X plus H.
Good. And what to plug in here?
F of X.
What to plug in here?
X plus H.
And what to plug in here?
X.
What happens to the x's down here?
Cancel. Cancel.
And somebody tell me what we have left.
Yeah. Over 8.
So somebody tell me what is the difference quotient? A fancy way of writing the what?
Slope.
All it is. And once you understand that, the I'm confused, I have no idea what's going on goes away. The difference quotient is a sophisticated way of writing the slope. Now, you just have to know what to do now. Because now, this is the algebra part. There's no calculus in this. None. All right? But, when you go back to the question, they're going to give you the function. And I'm not going to deal with the first two. I'm not worried about that because that's just steps you're going to do what I'm fixing to do right now. So, here's my function. So that means wherever there's an x, I've got to plug in something. So my difference quotient says f of x plus h minus f of x over h. So what I'm going to do is I'm going to rewrite this function in terms of, I'm going to put a big set of parentheses, 8, and I'm going to put a red set of parentheses where there's an x, plus 5, and I'm going to put brackets around that, minus, what is f of x? F of x is 8x plus 5. Over h. Now somebody tell me, what am I going to plug in to that? What am I going to plug into this red set of parentheses here?
X plus H.
X plus h. Now do your algebra, because it's 100% algebra. This is why people suck at calculus, because they suck at algebra. All this is algebra. But it's fixing to morph into, with the limit theory, it's fixing to morph into calculus. But if you suck at algebra, you're going to suck at calculus. And if you suck at difference quotient, then you're going to suck at calculus. So you got to learn. This is. I'm glad you sent this question in because this progresses us to the last part of the review unit, which is the difference quotient. And this is, I wouldn't doubt you don't see probably 6 to 7 questions on a 10-question test. This is going to be the 7 questions, 6 or 7 questions. Because I'm going to hammer this and hammer this and hammer this. Okay? So, here we go. What's 8 times x plus h? Well, that's 8x plus 8h plus 5 minus 8x minus 5 over h. Now, what happens with the difference quotient at the very end? A lot of things, what?
Cancel out.
Is that a sign that you're on the right track? Yes. Let's see what cancels. That cancels with that. That cancels with that. The product of the difference quotient is all H terms or numbers.
Oh, what are the H's and
Say?
I was just kidding.
Okay, so that's going to give us 8H over H. And I think that's what you're saying. The H's do what? Cancel. And you're left with, what's the answer?
8.
8. Now, 8 is a very interesting number. Sometimes you're going to come out, most of the time you're going to come out with a variable. But what this is the slope of this function. Now, why is it the slope of the function and not the equation of the slope? Because this function is a straight what?
Will it always be the same?
Yeah, it's always going to be the equation of the slope. Now, I'm fixing to take a jump right now again into calculus. All right? I'm fixing to take from right here, I'm going to go back to the whiteboard and show you where we're going with this. All right? Because this is very, very, very important. Let me go to the whiteboard now. This is algebra. And I'm going, oh shoot, I want to clear it. Let's say we have a f of x is equal to x squared. And y'all know that that function looks like this, right? Now I want you to do the difference quotient for this function. So do it. F of x plus h minus f of x over h. Okay, go ahead and do that. Just like we did in the last problem. Now I'll start you off. You take the x squared. I'd write a big set of parentheses. I'll color them red. Squared minus, what's f of x? F of x is what?
X squared.
X squared over
H.
h. And what am I going to plug in here?
X plus H.
And there's shortcut number 1 again. One of those things that you never will get rid of until you graduate your mathematics. So what will that give you in the red parentheses? Shortcut number 1 will give you what? X squared plus 2xh plus what? H squared, Hubert. That's right. Minus x squared over what? H. And take your red marker, and what goes out? That, and I'm going to rewrite the top. I'm going to factor out of h. I'm going to factor out of h. That leaves you with 2x plus h over h. And what happens to the h's right here? They cancel. Oh no, well, we left with a variable. Yeah, you're right. 2x plus h. Well, that's not a number, Hubert. That's got a variable in it. That's right, and that's where the limit comes in. Now, the limit says, and I'm just going to give you a quick definition of a limit. Let's say that you're facing a wall. You're turned perpendicular up against a wall. That wall right there. And I take a full side step. And each time I take a side step, I take half of the previous side step. Is everybody listening? Okay. Will I reach the wall? You never will reach the wall. Why?
Taking half side steps.
Take a half side step. So let's say you've got a long stride, and the first side step you take is 4 foot. What's the next step?
2.
What's the next step? 1 foot.
1.
What's the next step? What's the
Half.
next step?
1/4.
1/16th, 1/32nd, 1/64th. Mathematically, you never reach the what?
The limit.
The wall. You never will reach the wall. It's called converging. You're converging. Now, there's a reason I'm showing you all this. I'm going back to the problem we just did in just a minute. But let's say, and this is your definition of calculus, this is your definition of a derivative. If I put a point right here, and I want to know the tangent, right there, which is your slope. If I want to know that point, there's no way I can do it with the law that we used back in algebra. This is the law we used in algebra with the y sub 2 minus y sub 1, blah, 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 right? Because that's a straight what? That's a straight line. That straight line right there is in the interior of the curve, which means it is called the secant line. Now, it's very important for y'all to understand this. So I hope y'all not blowing this off. I hope y'all are paying attention, because this is where the calculus, this is where the rubber meets the road. Now, here is the blue dot right here. Here is the red dot right there. Half a step, half a step, half a step, half a step. Will I ever reach the blue line? No. That's just like reaching the wall. Will I ever touch, will the red mark ever touch the blue mark? No. But what will it get? What will it do? It'll get right up within a hair's width of that blue line. All right? So the distance, what is the distance doing right here? It's going to what? H is going to 0. Will it ever reach 0? No. It never will reach 0, but it's going to 0. That's the definition of a limit. What a limit is basically saying that you're converging onto that blue point. Now, as I converge onto that blue point, this blue line, this red line, let me get a green line here. As this comes down, and this comes down, as this thing gets within a hair, this red line gets within a hair of that blue dot, this secant line becomes what? The tangent line.
Oh God, I remember these.
Okay? The red line becomes the what? The green line. Because that red dot gets right up next within a hair. Now you got to think out of the box. You can't be redneck disorder here. You got to think out of the box. How close is a half of a half of a half of a hair? I mean, you're talking about a micromillimeter. All right, we're talking coming right up next to, right up within a hair. So you're talking about real close. All right. You ever heard the saying, it's close enough for government work? Okay, well, for all intentional purposes, that green dot is close enough for us to do this math, okay? All right, when that happens, that red line turns into the green line. Now, what does X approach? So we might as well say that the distance between the blue line and the red line is basically the green line, which is the 64 widths of a hair. It's basically what? 0. So what happens to this H when we apply limit as H approaches 0? What happens to this H? And this right here, write this down, this 2x right here is called the equation for the slope. Now, why is that a big deal? Well, before, in algebra, you couldn't tell me the slope of a line at any point on a curve. Why? Because you didn't know this. You would have to take 2 points, and you would have to draw a line, and you would have to give me an approximate slope. Now, look here. Let's say that this point right here, -1, -2, -3. Let's go with -3. All right? I want to draw a line right here. Now tell me the slope of that green line. Well, this point right here is -3. -3 times 2 is what? So the slope of this line, this green line here, is -6/1. What about the slope at 16? 16 will be way up here. What is the slope at 16? 32. So the slope at 16 is equal to 32/1. Now before, in algebra, you would have to go, okay, well, I don't have, I can get a point here, and I can get a point here, or get a point here, and get a point here, and draw a line. That's what? That's an approximate. But now, if you take the limit theory and you put it with the algebra and the difference quotient, you put those two together, and now you have calculus. Now, the reason I showed you this, and I'm going to show you this again when we get to it, the reason I showed you this is when you get back to the problem we just did. Where is it? Oh, it's on the whiteboard. Why did this come out to be just a number instead of a number and an x? Why?
Because it was a straight line.
Because it's a straight line. And that's what you're supposed to come out with. Now, what is this number compared to this? Well, this number, what you get when you do the difference quotient and you do the limit theory, is called the derivative. That's called the derivative. Now, when you don't apply the limit theory, it's called the slope. That's why this is the slope. That's why I didn't write derivative right here, because I didn't apply the limit theory. I can't apply the limit theory because it's not a curve, it's a what? A straight line. Now, you would be surprised on how many students take calculus and they go through the unit 1 and have no idea what a derivative is. You would be surprised.
Would it still be an 8?
Yeah, that's still 8. Nothing changes because it's a straight line. So, hopefully, this right here is a good question. Whoever sent it, Mr. Granger, where are you at?
Right here.
You did good. Because that is a very important question for everybody to make sure you can do. Make sure you can do 5 or 6 of these. Okay?
5 or 6. All right. Start out.
All right. Anybody got a question on this? Now, this right here is just parts of this. So you should be able to get the parts right there. Okay? It's got another question down there. Evidently, it takes all the questions that he sent and it puts them in. That's a good thing.
What? You can just scroll down.
Yeah, that's a good thing. All right, so I'm going to hit this right here, and I'm going to scroll down. Mr. Granger, is this the second question you sent right here?
Yeah.
Is that it?
I believe,
Is that
yeah.
the second question?
I believe so.
Okay. It says rewrite the given pair as one composite function. Okay, g of x. All right, let's go over this right quick. This is your composites. This is where you use substitution. So y'all did substitution all through Algebra 1 and 2 and 109 and 110, whatever. So it's just, now this book does not write it because this book sucks. This book doesn't write it like it's supposed to be written. There's 2 ways. There's g of f. I'm going to take a quick review here. F of x is equal to x plus 3. G of x is equal to, I'm going to do something, square root of x plus 2. Okay? Now, g of x, if I tell you to write f composed of g, that's fog. Okay? That means I'm going to rewrite this guy right here with big A parentheses. Okay, so I'm going to rewrite f of x with a big set of parentheses. So I'm going to take my red parentheses and I'm going to rewrite the f of x, and then I'm going to put plus 3. And then what does the composed of g, what does this right here mean? Plug into. So, what is g of x? G of x is the square root of x plus 2. And your final answer, f of g, is the square root of x plus 2. Put a little tail right here so you know that 3 doesn't go under there. Plus 3. Now, what if I ask you to write g of f? G of f of x. God. Well, that means I'm going to rewrite g with a big set of what? Parentheses. And what am I going to plug in? I'm going to plug in f. So here's my red marker. Parentheses. Are y'all done? Y'all know this microphone just amplifies everything, right? So if y'all whisper, it comes in. And if y'all rattle a piece of paper, it sounds like somebody's just scraping the floor with a chair. Okay? So kind of watch it, all right? All right, so x plus 2 plus 3. I have no idea who was doing it. Just don't do it all the time. All right, x plus 2, that means, well, I done messed up. I done got my mind off what I was doing. All right, that's the square root of what? X plus 2. And then f, what am I going to do with f? I'm going to plug it in where? Right here. So, I can combine these two, so that's g composed of f is equal to the square root of x plus what? 5. What if I ask you to do f composed of f? What if I asked you to do g composed of g? What would you do?
Plug it into the cell.
Plug it into the cell. So, now look at this. Now the question that was sent was this. And you know how many times I get questions where the only thing is the student don't know what the question's asking? That's this question. This question is saying, okay, I'm going to rewrite it. F of x is equal to the square root of 7x squared. G of x is equal to 3e to the w. And they're asking for f composed of g of x. Now see if you can do it. I bet you $1 you can do it now because you know what it's asking. So which one am I going to write with a big set of parentheses? F. So the square root 7 parentheses squared. And what am I going to put into place?
3e to the w.
3e to the w. And what's 7 times 3?
21.
And e to the w, whoa. I messed up. Made a classic mistake. 7, parentheses, 9, e to the 3w. And now 7 times 9 is what? 63, e to the 3w. And now you need to focus on what? The square root of 63. Square root of 63 is square root of 9 times square root of what?
7.
7 times square root of e to the 3w. And 9 is what? 3 square root
3
of
square
7 e to the 3w. Okay? And I think that's what they got, didn't they? Yeah. Well, they should, wait a minute, they got 2w. Oh, because 2 times w is 3w. I'm sorry, my mistake. I must have, sometimes that happens with me. I'm thinking of square root of 9 is what I was thinking of. Sometimes I do that. I get a number in my head and 2w. Thank you. Now, what in the world does this mean? That means f composed of g and plug in what? Plug in 1. So what's 1 to the, well, it pulls in is, let's see, g of x. Oh, e to the 2, okay, they plug in 1 for w. So e to the second power, do that in your calculator, times 7, take the square root of it, multiply it by 3. You should get 21.58. So let me do that. I'll just put it right here. 3 square root of 7 e to the 2 times 1. And that's going to be 3 square root of 7 times e to the second. E is 2.5 something, so that's 4. Might as well say 5. The square root of 35, the square root of 36 is what? 6. So 5.9, and multiply 5.9 times 3, 5.8. 5.8 is going to give you 15, 19, 20. It's going to be around 20. So I don't know what it is, but
To the square root of 7.
no, right here, e to the second power. What's e to the second power?
Well, e to
Okay. I said 5, that's why I'm off. Multiply by 7, what do you get?
How's that?
Take 7 and multiply by e squared. What do you get?
Okay. 7.
I got 21.57.
I know that. But what
51. Yeah.
what is e squared times 7?
I got 51.73.
And then what's the square root of 51.2? 7 point or something
7
like
point,
that.
yeah, 7.19.
Oh, sorry. And then 3 times 7.1, 7.2 is whatever the answer is.
21.57. Yeah. Or 21.
Okay, so hopefully that helps. On a test of 10 questions, this might be one question. Trying to give you an idea of what's important and what's not. It's important, but the reason it's important is because they're getting you ready for the difference quotient. They want to make sure you can turn in. Where's Pendleton?
Right here. Yeah.
Oh, I'm sorry. The microphone was turned to the, I thought, okay, nothing. I thought I was looking at my screen here. I'm sorry. I thought y'all went offline. Okay. Sorry about that. Next question. Let's see. That was 2 questions. Oh, can't believe I just... Sorry. I hit the wrong minus symbol. I was trying to get out of the whiteboard, and I hit the wrong... I'm sorry. Today's just a screw-up day. Just give me a second. Let me get back to WebAssign. Sorry. Okay, y'all got to remind me whose questions that was. Mr. Gaines, I think, right?
No.
Granger, sorry. That takes care of that one. So I need to hit this, And I need to send to answered. That should be, huh?
Don't you have to move the second question right there?
Do I have to move both of them? Good God. This thing is so primitive. All right, next one. Next one is, just waiting on it. Oh, I got to hit refresh, haven't I?
Yeah.
School of Technology. All right, make sure you can do these. Now, you can do these in the calculator, or you can do it, and the reason I put these in here is because a lot of people don't know how to use your dang calculator. All right, so anytime you do, and these are the properties of logs. These right here. Now you can do it in a calculator, but anytime these two right here match, your answer is going to be 1. That's a property. Okay? Any log of 0, and I'm going to put log base n of n will always equal 1. That's the property there. Log base x of 1 will always be what? 0. Log base x of x to the n power will always be n. So those are the 3 properties right there that you should remember. Now, those of you that are, suck at logs, you need to go ahead and pull up 2 things on Google. Okay, you need to Google, I spelled it wrong. You need to Google properties of logs, and the definition of logs. The definition of logs has a y is equal to log base b of x, which gives you y is equal, or x is equal to y b to the y power, I think it is, or y to the b power, I can't remember. It's going to give you a property right there, and that's very important. Now we're going to go over when I get to a question. I'm going to go over it when I go over logs before we go into the unit test. But right now, these are the 3. These 3 right here will be the first ones in your property of logarithms, and we went over that back in 109. Okay.
I think I got it wrong. Why not type in different than the calculator?
Oops. Okay, next one. Next question. Let's see. Let's move down. Let's see. Okay. Not going to do that. Okay, I thought it had more questions, but evidently it doesn't. So I'll have to go back and pull everything up. There it goes. All right, now this one. You'll see this one on the test. Anytime you see a logarithmic equation, you're going to see it on the test. Now, this is going to be using the definition of logarithm. Definition of logarithm. Definition of a logarithm says y is equal to log base x or base a of x. And I can't remember the second part. I think it's a to the y. X is equal to a to the y. We'll find out in just a second if I'm right. All right, so which one is this one written in? You look right here and you say, okay, it's written a little bit different, but it looks like this. 2 is equal to log, and what's the log? If you don't see a base, what is it assumed to be? 10. Good. log base 10 of 6x plus 5. Now, y is equal to log base a of x. So now you can get your y is equal to 2. A is equal to what? 10. And x is equal to what? 6x plus 5. So now, if this is written like this, then what are we going to write it as? We're going to write it as that. So 6x plus 5, that's my x, is equal to what? A is what? 10. And y is what?
2.
And now you've got a pre-algebra problem. So go ahead and finish it. 6x plus 5 is equal to 100. 6x is equal to 95. And x is equal to 95/6, which that is the end. All right. Next question. That takes care of these two. So, move to answered. I got to refresh. Primitive. And Mr. Granger again. Okay. Same. Okay. Different types. Different type equation. Again, another very important question. So we've got, you sent one question which was difference quotient, which was very, very, very important. Then you sent, somebody sent, I think Miss Connor sent the log of the definition of logarithm, and now you got this one. So there's 3 questions. Well, probably talking about on a 10 question test, which I'm just saying 10 because of number. You probably got 6 or 7 questions right now. You've got 5 or 6. You've got 5 of the difference quotient and then 2 logarithms. So you start to see how your test is going to line up. Now, what do you do here? You take the natural log of both what? The natural log of both sides. Why do you do that, Hubert? Because what happens when you take the natural log of e? Cancels out the natural log and the e, and you're left with just the exponents. And there's 2 things you can do here. E to the 4x. There's 2 properties you can use here. Somebody named the second one. I said the first one. Take the log of both sides. What's the easier one?
Same.
I'm sorry, I heard it.
Same base.
Golly, you had it. Who was that? Good job. I'm impressed. Same base. Take your highlighter and highlight. The reason I'm impressed is because, you know, when you take an algebra course and you finish it, you're supposed to what with the material that you learned? You're supposed to forget it, right?
Oh, yeah.
And everybody forgets it. And it's very unusual for somebody to remember it, okay? So, I'll be sarcastic. All right. If the bases are the same, what can you do to the exponents? Let them equal to each other, Hubert. Yes. And when you take the natural log of e, that cancels that out, and these fall on each other. So you're left with x squared plus 3 equals 4x, or x squared minus 4x plus 3 is equal to 0, and then what can you use? 2 things.
Complete square.
Completing the square or reverse.
Foil.
Exactly. All right, that's that one. Move to answered and refresh. And next one. Okay, let's look at this one. Now, a lot of people say, well, why you want to do this one? Well, this one, they should at least, it looks like to me, okay, compounded semi-annually, you got to know the two formulas. One is equal to P times 1 plus R over, I'm not going R over N raised to the NT power. The other one is P E to the RT, and I'm just going to pull them up right quick for you, okay? One is E to the RT, and the other one is 1 plus R over N raised to the NT power. But I'm just going to pull both of them up for you. Compound, I can't spell compound, is that right? P-O-U-N-D. Compound and,
Continuous.
thank you, continuous interest formula. And this is a lot of work. I know y'all, it's a lot of work for y'all to Google something. But anyway, there it is. Write that one down, P-E-R-T. I just wanted to make sure I remembered it correctly. And then the other one is right here, P, 1 plus R over N raised to the NT power. I just want to make sure I remembered it correctly. Down here where the hand is. Back a long time ago, there was a shampoo called Pert. Just remember Pert? They still have it? You kidding? Yeah. Pert. And of course, there's your formula here. Now, what is the number one reason students can't do these formulas? Anybody want to take a guess? They don't know what's what, exactly. Okay, so, and is this one an important one for the test? It could be, but I would rather you focus on the other. This is a problem that's best in real life. Okay? It's best in real life because this is what a lot of your banks use. They derive formulas based off of these two formulas for your savings accounts and things like that. So it's kind of nice to know so you don't look ignorant in front of the bank manager or the loan manager or whatever.
I sent
So,
that in.
say again?
I sent that in. I couldn't figure out how they got option A.
Well, let me go through and do the whole thing, okay? Hold on just a second, because I have no idea what it's asking. All right, this right here is called P. That's your principal. Principal, like, you know, P-L-E, not P-A-L. This is your R. Both of these are your R, which means your percentage what? Rate. This right here, semi-annually, means what?
You're in.
It means N, okay? That's your N. And in this case, N is going to be equal to what? 2. All right? Because it's done twice a what? Year. And it's going to say it's going to keep you how many years? Somewhere it's got to give you years.
Not at that point.
Okay, well then they'll just say N is equal to 1. Okay, right here they do. Okay, calculate the annual percentage yield. Okay, the annual percentage yield, does somebody have that one? Annual percentage yield is APY. Has anybody got that formula handy? It's real short. What is it? Anybody got it
What
handy?
is it?
APY.
I
Or somebody Google it right quick. It's just a simple formula. New minus old over old. This question is really out of place.
1 plus R over N to the N minus 1. All right.
1 plus
R over N.
R over N.
Parentheses to the N.
Parentheses to the N?
Yeah.
Okay.
And power minus 1.
Minus 1 right here?
Yeah.
Okay. I teach a business. I teach the 103. Never have we used that.
Yeah.
But
and it says the R is the stated annual interest. interest rate.
Yeah.
And is the number of
Different.
loans compounded.
One thing you can remember, all of these are going to be the same no matter what formula you use. Okay? So 1 plus, the first one is 5.725, which is going to be 0.05725 over 2. So we're going to raise that to the second power and minus 1. And when you do that math, you should get the 5.807. When you do the E, that's going to be equal to 1 plus, and the 5.625, 0.05675 divided by what? 2. And that's going to be minus 1. Okay? And that should be just a little bit more. Always remember, these two guys compounded continuously and compounded whatever, they're going to be usually very what? They're going to be just about the same. Okay? That's approximately. So that's why you get 5.839 versus 5.807. Now, after 5 years, this is your T. T is usually written in terms of what? Years. Now, it's very important that you remember this, because what if I give you 6 months? What if I tell you that you're going to keep the money in your savings account for 6 months? And T would be 0.5. Yes. You have to remember that. So 6 months, and you need to write that down. 6 months is equal to 0.5 T, or equals T. Because that's where students mess up. All right. Now, I have no idea what the question's asking next. We'll move it down and see. Calculate the future part of each investment after 2 years and after 5 years. So I'm going to write the formula. A is equal to P times 1 plus R over N raised to the NT power. And A is equal to PER, P-E-R to the T, is that to the RT? To the RT power?
Yeah, you're right. That's right.
To the RT power? Is
Yeah.
it raised to the RT right there?
Yeah.
Okay? And P here is going to be, I forgot, 4,500?
Yeah.
So that's 4,500. 1 plus 0.0508, hold on.
I can't remember the interest.
There it is. 0.05725. 0.05725 divided by 2. N is 2. And here you can, okay, I don't know how they're doing this. Okay, 2 years right there, 2. So 2 years here, and that's going to change. So I'm going to put that in red. Okay, and right here is going to be A is equal to 4,500. E to the R is 0.56. Okay, it's going to be the same. Okay, we're doing the same. Okay, 0.05725. 0.5725. And T is 2. Okay, now crank those out in your calculator, and you should come up with 5037 and 5040.
Why are you using the same rate if option B it's got a different
Said-
rate?
Okay, I'm sorry, I'm getting them mixed up. Okay,
They're
so
two different columns. They just use the same
okay, option B
computers.
is right here. Okay, thank you.
Yeah.
I knew I was supposed to use one of them. Sorry, that's 0.05675. 0.05675. Sorry. All right, now run it through. Now, basically, what they're trying to get you to understand is that continuous interest and regular compounded interest really don't make what? It doesn't. You're talking about what? $6? How much on the
You're
second?
talking about $3 from option A to B. It's
Yeah, but the second one.
the second one, yeah.
You're talking about $6 or $9. Is that going to make a difference over a 5-year period? No. And I think that's what they're asking you. Does it really make any difference? No. Okay? Is this question important for the test? No. Okay? I mean, I'm glad you sent it. I'm not saying it's not an important question. It's an important question for out of this class. But it's not important as far as the things I'm trying to hammer for unit 2. Okay? So, it's a good question, but not a good question as far as importance for the test. So you need to put a 0 or a 1 on that one as far as importance. You may see it, but chances are you won't. Capiche? All right. Nick, did that help with your question?
Well, I'm still working on the verification.
Oh, okay. But do you see where I'm getting the numbers?
Getting that annual percentage yield helped a lot.
Yeah, well, I'll be honest with you, nobody ever uses that.
I did it.
Well, as far as a business math, we don't hardly ever use it.
Option A, I was stuck on there. Figure out to use the whole compounding interest formula for it. So trying to figure out why they keep on doing percentages.
Yeah. Well, the percentages, like I say, you just change them to decimals and just crank them in. You should be able to get those numbers with those two. And instead of plugging in a 2 here for the second one, you plug in a 5. Okay, I'm going to move on. I'm trying to get as many done today as I can. So, all right, next one. I got to refresh. Hold on. This is so annoying. Okay, this is 1.3. Let's see, 1.3. Graph indicate. Okay. This is not a very difficult question. It's a question that you got to remember your limits, and this is what we were talking about before, approaching from one side or the other. So if you look, do you see the minus sign here? You see the minus sign, you see the plus sign, and you see that sign, no sign? Well, that basically means you're approaching from the left and you're approaching from the right. All right? Is everybody listening or are you talking? All right. Approaching from the left. As I come from the left on this function, just like the plane, all right? If I come from the left and that plane's coming down through here, what y value am I approaching? 2.5. And that is what the limit is. The limit is in regards to the what? The y value that you're approaching. All right? And some of you that had calculus before, it's called the squeeze theorem. The more you come in here, the closer you get to the y value. In this case, if you come from the right, you're approaching 2.5. If you come from the left, you're approaching 2.5. So the y value that you're approaching is 2.5. And that's what they're saying. If this matches this, then the limit is 2.5. Now that is a review. If these two match, if these two are equal, then the limit of the function is that number.
What if they're not equal?
They're not equal, then the limit does not exist, or it's or it's not continuous. But this, as far as a test question, 1 or 0. Okay? Just get them done on the homework. The main thing I want you to see here is the approaching that we talked about. What I'm trying to get you. Okay, let me just say this. In the Unit 1 review, there is 90% algebra that you need to review. 10% is thinking out of the box that you need for the derivative, for the calculus concept. This is a thinking out of the box. This is not bare bones algebra. This is thinking out of the box. If you approach from the left and the right on that absolute value function, if you approach, what y value are you approaching? And you should all say 2.5. Okay? That's all I want you to see out of this problem. I do the same thing with my Math 140s. I want them to think out of the box, but I want them to make sure they know their algebra. This is out of the box. So make sure you know what it means. All right? And let's see, next one. Let's see. Same concept. All right? What is this function doing as it approaches from the left? It's going to infinity. Right? What is this one doing as it approaches from the right? It's going to what? 2.5? 3?
Negative.
Okay. Negative 3. All right? In this case, you've got something that's totally different. All right? And since you can't put your finger on infinity, the function is at negative 3. All right? These two do not match. But somebody tell me what number is infinity. That's what I thought. Okay? So you're going to have to use that negative 3 there. It is not continuous. Well, I usually tell people, you know, when you're playing with your cars when you were little, you used to jump over a little ramp. Do you have to jump a ramp to get from this side to this side? Yes, it's not continuous. You have a gap. A gap usually means not continuous. Again, thinking out of the box, that is not detrimental to you being able to do the hard mechanics of calculus. Okay? Next question. Again, another one. I think I've got that. Now, as this one approaches from the left, you are approaching 0. Wait a minute. Okay, no, look, it's saying from 0. Okay. As I approach 0 from the left, as I approach 0, x is approaching 0. So that means x approaches 0.
It hits at 3.
It hits at 3, up there below 4. And as I approach from the right, g of x is going to be... I know what they're talking about. They're not talking about this function right here. If I approach from the left and approach from the right, there we go. If I approach from the left and the right, then what am I approaching?
3.
I'm approaching 3. If this one approaches 3 and this one approaches 3, this function is at 3. Is it continuous? Yes, as far as what they're asking. As far as these two right here. Okay? Now, a lot of people are saying, well, what about the bottom one? Well, the bottom one is x is approaching what? 2. 2. Doesn't say anything about 2? No. So you got to read it. They might ask a part or something. But again, thinking out of the box. I promise you this review will pay off when we get to the limits and we get to the actual thinking, okay? All right, I'm going to kind of skip some of these because these are the same type questions. Let me get out of this. I'm going to have to move answered, refresh. Okay, 1.7. I think we've covered 1.7. Let me do completing the square. We've covered that. 1.2. What is that? Let's see what 1.2 is. Okay. This question, okay. This is a calculator question. So you get your calculator out. And it's out of box. It's a little bit of algebra. You know, what does it look like? But it's still out of the box because it's asking about the limit. So the first thing you want to do is put this in the calculator. So you're going to put it in as 59 divided by y is equal, or graph y is equal, hit the y is equal, and put 59 divided by 1 plus 0.5 e to the negative 0.1 t. I have no idea what it looks like, but you should be able to answer those questions after you put it in. Okay? And you need to use the trace button. The trace button will tell you what you're approaching as you're moving toward negative infinity, as you're coming from positive infinity. Okay, we're going to stop there. And because with the zipping before 3 minutes before classes is, even though it's rude, I'm going to pretty much say that class is over because somebody's dictating to me that I need to end class. Okay? So whoever that is, please don't do it anymore. Okay? All right. Now, if I go over, if it's 1 minute after 11, then you can make all the noise you want to, whoever that was. But it's not. By my clock, I got 3 minutes. All right. Now, I'm just going to go over the roll right quick because some people are missing. And I know it's a review. And I know people are not coming because of review. And that's fine. But I need to know who's here and who's not. All right. Now you can back up. Anderson campus, Clayton. Clayton. Crittenton. Holland. Wall. Latham. Sarver. Smith. Batakis is here. And Looney is here, and Connor is here. All right, y'all have a good weekend. All right, Pendleton campus. Let me, since y'all are the biggest group, get y'all next. Let me turn this off right quick. Sorry, hold on. Where is there it is. Hold on just a second. Stop recording.